Okay, so till last class we have studied the universal law of gravitation. We have seen the derivation, that how we have derived, how we have come onto this conclusion, what exactly is meant by the universal law of gravitation. Now let's understand what exactly is the importance of this particular law. Okay, so next we will understand the importance of universal law of gravitation. Okay, the universal law of gravitation. The first importance of this law is, the first law, see, basically what we understood, that universal law of gravitation means that two bodies attract each other, okay, with a force which is proportional to the product of their masses and inversely proportional to the square of distance between them. So the first thing, the first importance is, it generates the force that binds us to earth. Because of the law of gravitation, there is a force generated which binds us on the earth. Okay, because of this law, because of this force, we are standing on the earth. See, I am standing here, I am standing on the earth. The reason is simple, that earth is attracting me. Okay, I have some finite mass, earth has some finite mass, and the force between us is the product of, it's proportional to the product of the masses of my mass and the earth, and the distance, the inversely proportional to the square of the distance between me and the earth. Earth means I am talking about the center of the earth. So the earth is attracting me with a force, okay, which is equals to F is equals to G m1 m2 upon r square, okay, and that's why I am able to stand here. Imagine that if force, this type of force does not exist, what will happen? I will start floating in the air, okay, because there is no force. So if you go to the space, you will find that if you go in the open space, you will start floating around. Okay, the reason is simple, that there is no force, no a finite amount of force, okay, which will bind you towards a single planet. Okay, that's why the force that binds us is because of the universal law of gravitation. Okay, this is the force. The second force, okay, for example, let us say that this is a diagram, this is the earth, and this is a human being which is standing on the earth. Okay, he is a human being, he is standing on the earth. Okay, so there is a force between them. This human being is attracting earth towards itself with a force, let us say F, and this earth is attracting the human being with a force again which is equal to F. Okay, let us say the mass of human being is mh and mass of earth is, let us say, me. So the force between them can be written as G times me into mh upon the distance. Now if I talk about the distance, then I am talking about the distance between the center of the earth and the human being, that is this distance, let us say this is r. So G me into mh upon r square. This is the force by which earth has attracted me towards itself, so that I am able to walk on the earth. Okay. The second importance of this force is, you can see, you know what is moon. Okay, from your childhood you have heard many stories about the moon. So second thing is the motion of moon around earth. The motion of moon around earth is again due to the force, again due to the universal law of gravitation, again due to the force that is generated according to the formula G mm by r square. So what we can say here, if I talk about earth, let us say this is the earth and this is the moon. So we can see that moon is continuously revolving around the earth. Okay, moon is revolving around the earth in this way, in a circular path. So have you ever thought that why shouldn't it happen that moon shoots away in this direction or moon shoots away in any other direction? Why is that moon is binded towards the earth? Why is it that moon is continuously revolving? Why should not it leave the earth periphery and it should move into the space? Why this is not happening? It's because since these are the two bodies, let us say mass of moon is mm and mass of earth is me. So there is a force of attraction between these two, and that force F is equals to g times mass of moon into mass of earth upon square of the radius, okay, or we can say the square of the distance between the two. Distance between the two means I am talking about the center of moon and center of earth. So this distance I am talking about r upon r square. Okay, this is type of situation. We can see that moon has a small mass, it's comparatively very less, okay, it's almost 1/6. We will learn about this concept in the upcoming topic. The mass of moon is almost 1/6 of the mass of the earth. That's why moon will revolve around the earth, but not earth will revolve around the moon. This would be the concept. Okay, so the moon will pull earth towards itself with a force F, and earth will also pull the moon towards itself with a force F. But since earth is a large object, it's a bigger object, that's why moon will start revolving around the earth. Okay, this would be the situation. Okay, the third importance of the gravitational law is motion of planets around sun. The motion of planets around sun, it's again the result of the law of gravitation, because you can see in our solar system the planets are bound towards the sun. Okay, they are not leaving the sun, they are not leaving the solar system. The reason is simple, that the sun is attracting them, the sun is applying a force, okay, which is huge compared to the size of the planets. Okay, the force is very, very huge. That's why the planets continuously revolve around the sun. Okay, they will not leave their path. Let us suppose this is the sun, and we can see the planets revolve in this type of circular object. Let us say this is P planet. Okay, the planets, let me correct it. The planets are comparatively very, very small. Okay, as we compare it to the moon, even the Jupiter is very small compared to the sun. This is like a planet. Okay, it's again a bigger size. This would be the planet. Okay, this would be the planet. You can see the planet would be very, very small compared to the size of the sun. That's why, let us say the mass of planet is mp and mass of sun is ms. So there is a force between them which is equals to g times mp into ms upon the distance between them. The distance between them means the center of the sun and the center of the planet. So I am talking about the distance, this one. This is the distance r between the sun and the planet. So the force of attraction will be g mp into ms upon r square. Okay, so what we can see here, the important point here is the planet is attracting sun towards itself with a force F, and the sun is also attracting the planet towards itself with a force F. But the size of the sun is comparatively very, very large. Okay, almost 1000 times more than what is the size of the planet. So that's why what we will see, the planets will start revolving, and this force F will bound the planet to revolve around the sun. Okay, the planet cannot leave its orbit in that direction or in this direction. Okay, because sun can apply the force which can definitely help the planet to revolve around. Okay, there is a bigger concept in this, but that concept you will learn when you learn about the physics in your class 11th. But we talk about if a basic concept, then we will simply say that this force F will bound the planet, okay, will bind the planet to revolve around this circular orbit. The planet cannot leave in that direction or in this direction or in any direction. It has to revolve around this, okay, because sun is continuously attracting the planet towards itself. Okay, so this is the third application, the third importance. And if I talk about the fourth importance, then tides in ocean on full moon. You have heard a lot of stories that there are tides, okay, high tides in the ocean, in the water whenever there is a full moon. So why this kind of situation is happening? It's because the sun, because of the moon, because when there is a full moon, it means the moon will apply a force. We can see here the situation. The moon is continuously attracting Earth towards itself, but since the Earth is a huge ball, it has more mass compared to the sun, so it will not get attracted directly towards the moon. What will happen? The water on the earth will face some attraction towards the moon. So if I talk about, let us say this is the earth, this is the surface of the earth, and here we have a moon. So what will happen? The water on the earth, it will get attracted towards the moon and it will form the tides like this. Okay, let us say this is the water and this is the tides. So these tides are due to the full moon. This is due to the attraction that moon, okay, it is due to the attraction of the moon towards the earth. The water that is present on the earth, it will get attracted towards the moon, on the full moon, okay, because the mass of the moon, we can see mass of the moon is large compared to the water, the mass of the water, okay, that's why. I am not talking about the complete earth, I am only talking about the water in the ocean. So that water is get attracted towards the moon, and due to this attraction there would be high tides. You can see the water will jump almost, we can say that around 30 to 50 meters, okay, from the ocean, and that we call as the high tide, and this high tide is due to the moon, okay. And you can also see in the evening times, the ocean, in the evening times the tides also get bigger and bigger. The reason is because in the night we can see the moon would be available, okay, moon would be on the side on the side of the earth where there is a night, okay. So that is due to this reason that the tides will get bigger and bigger, and the time when the full moon comes, okay, the tides will become almost huge, okay. It's 30 to 50 meters of high tides you will be able to see in the ocean. It is due to the attraction, okay. The moon is continuously attracting this water towards itself. Let us say that mass of the water is mw and mass of the moon is mm. So the force between them would be G times mw into mm, and you can see the water will also attract the moon and moon will also attract the water, but what we can see, the mass of the moon is large compared to the mass of the water. So this would be the force, and the distance if I talk about, so center of the moon and the water, I am talking about this distance, let us say r. So I will say that it's G mw mm upon r square. This is the force by which the water on the earth will get attracted towards the moon, okay. So these are the four important points regarding the universal law of gravitation. So first you note this and then we will continue our topic. So we have learned about the universal law of gravitation and its importance. Now related to this topic, let's continue our discussion and we will understand a very, very important term, and that term is free fall, okay, free fall. Now what exactly is meant by free fall? You will see that you might have observed when you throw a ball upwards, okay, when you throw a ball upwards, it will go till some distance, okay, then it will stop and it will start falling down. Have you seen the path of the ball when it starts falling down? Have you observed that how does a ball when it thrown up, it stop at the in the sky and starts falling down? You would be able to see that the ball falls in a straight line. You will not see that if you throw a ball it will move in like this, it will move in a zigzag or irregular path and fall on the ground. You will find that it will fall straight down on the ground, okay. So what exactly is happening? When you throw a ball upwards, why does it stop in the air? You know that it stops due to the gravitational force, you know that it stops due to the force applied by the earth, okay. The ball will stop at some point. So when the ball stops, why does it fall on the ground? Again the same reason, it will fall on the ground because the earth will not going to stop attracting that ball, because what universal law says that every two objects will continue to keep on attracting each other, okay, towards them, okay, with the force equals to g mm by r square. This is the formula that we have learned. So it means when you throw a ball upwards, it will stop at some point and it will start falling down. So when the ball is falling down, okay, when the ball is falling down, have you ever seen that the speed of the ball increases as it starts falling down? When you throw the ball like this, what you are doing? You are basically applying a force on the ball to throw it upwards. But when it reaches at some point and it stops and start falling, then there would be only a single force which will be applied on that ball, and that force will be known as the force of gravitation. Okay? So what I mean to say that when you throw a ball upwards, in that case what will happen? The ball will reach some height, okay, it will reach some height, okay. Just try to imagine the situation. You have thrown a ball, it will reach some height, okay, then it stops, okay. After reaching some height, the ball will stop. Then what will happen? When the ball stops in the air, after that it will start falling on the ground, okay, it will start falling on the ground. Then it starts falling on the ground. Now when it starts falling on the ground, try to imagine that what kind of force is applied on the ball which makes it fall on the ground, okay. Where is the force? Who is applying the force on the ball because of which the ball is falling on the ground? The reason is simple, there would be the force of gravitation, okay. So we will see that when the ball falls on the ground, okay, when the ball falls on the ground, while the ball falls on the ground, the force of gravitation would be applied, okay, because there is nothing in the air which can apply the force on the ball. You are not at the top and you are pushing the ball, it's not like that. The ball itself is going up because of your force, okay. Once it stops and it starts falling down, and that when it starts falling down, there is no force applied by you, okay. You have just applied to throw the ball up, you are not applying it to come down on the ground, okay. So which is pushing the ball, which is forcing the ball to come on the ground? That is the force of gravitation, okay, the force of gravitation. So what we can see, when the ball falls in the influence of gravitation, okay, you would see that the ball will fall in a straight line. You will observe that the ball will fall in a straight line. The path of the ball would be a straight line. And from here comes the definition of the free fall. Free fall means when an object falls under the influence of gravitational force, we call it as a free fall, okay. Try to understand it. I am saying that when an object falls on the ground under the influence of gravitational force, we call it as the free fall, okay. So let me write the definition. When an object falls under the influence of Earth's, okay, because we are living on the earth, so I am talking about the earth. When the object falls under the influence of Earth's gravitational force, okay, when it falls under the under the influence of gravitational force only, then we call it as free fall. Now read the definition very carefully. I am saying that when an object falls under the influence of Earth's gravitational force only. Now why I am saying only? It's because you have seen that when you throw a ball up and if there is a very fast wind blowing around, then you will find that the direction of the ball will get changed, okay. But at this point of time I am ignoring that point, okay. I am ignoring, or maybe happen that when you throw a ball, a bird will hit the ball and it will change the direction of the ball, okay. I am ignoring all such cases, I am ignoring all such practical cases. I am simply considering that there is no air, there is no air molecules or wind or anything, or no bird, anything, nothing is present there, and simply there is a ball and there is the earth, okay. I am not considering the air, okay. I am neglecting the force or the influence created by the air or the wind or the atmosphere. I am simply considering that you have thrown a ball up and the ball is coming down under the influence of gravitational force only. I am ignoring all such practical cases, okay. So it means when there is only the gravitational force available, then I will call it as a free fall, okay. Here we can say that we have ignored the influence of air or any such particle, okay. I am not considering the influence of any such particle, I am considering that there is a vacuum, okay. You are standing in a vacuum and you have thrown a ball like this and the ball starts falling on the ground, okay, and there is only the influence of the gravitational force. So what situation I am considering, try to understand this. This is the earth, okay, and you are standing here, somewhere here, okay, and you have thrown a ball up. So the ball will, what will happen? The ball will go up like this, okay, it will go like this, and then it will start falling on the earth after some point of time. You will find under the influence of gravitational force or under the condition of free fall, okay, this free fall, under this condition the object will fall straight on the ground, okay. It will not be like a curved path. Or have you seen a ball, if you have thrown it up and it will falling like this? Have you seen this? No, this will never going to happen, okay. So we will say that in free fall the object will fall straight on the ground, okay. You will find that under the free fall condition the object will fall straight on the ground, okay. So what exactly the situation is? The simple reason is that the earth, now you might feel that why is it happening that the ball is falling straight on the ground, why it is not a curled path, okay, why it is not some irregular path. The reason for that is very simple. The force that earth is applying on the ball is to attract the ball towards its center, okay. In the universal law of gravitation, what we have learned, that two bodies attract each other towards their center, okay, the center of the ball. So that's why what will happen, if you are standing somewhere here, if you have thrown the ball in this direction, the earth will try to attract the ball towards its center. Or might be possible that you have standing here, okay, you live at this part of the earth and you have thrown a ball in the air like this. So again the earth will try to attract the ball towards its center, okay. So the most important thing, in free fall the earth will attract object towards its center. Okay, the earth will attract the object towards its center, and that's why the path of the ball would be a straight line. Okay, the straight down the ground. Okay, so what we can understand from a free fall, that it is due to the gravitational force, it is due to only the influence of the gravitational force. The object will fall straight down the ground, its path would be straight. The reason is simple, the earth is attracting everything towards its center, and that's why the force will be this gravitational force will make the ball to fall straight down the ground. Now I am talking about a force. Okay, this is basically a gravitational force. Now whenever there is a force, there is the Newton's laws. Okay, whenever you have heard about the force, we can apply the Newton's law. So what we can see, according to Newton's law, whenever there is a force, there is a Newton's law, and due to Newton's law we can see that the force will create acceleration. Okay, because there is a force, you have learned this, that whenever you apply the force, okay, the velocity the velocity of any object on which the force is applied, that velocity will going to change. So what does it mean? It means that whenever there is a free fall, there would be the change in velocity. Okay, try to link the situation. The free fall is due to the gravitational force, and since we have the force, force means the acceleration. Force is related to acceleration by the condition Newton's law. Which condition? Which Newton's law? The second law. Okay, the second law that Newton has given, that according to that law we can write force is equals to mass into acceleration. Force is basically the product of mass and acceleration. Because of this, you will see that since there is a gravitational force, there would be the acceleration. Now the important condition here to note is, F is a force. Okay, F is what? It is the gravitational force, or we can write it as force due to gravitation. Okay, I will write it as the force due to gravitation. This is the force due to gravitation. Okay, and since this is the force due to gravitation, I can see this acceleration. Now why this acceleration is happening? I am talking about the free fall, when there is the earth's gravitational force only. I am not talking about any force. In this situation, since this force is created by force due to gravitation, we call this acceleration as acceleration due to gravitation. Okay, so now try to understand this concept. This is a very, very important concept in this chapter. I am talking about free fall. Free falls is due to the earth's gravitational force. Now wherever there is a force, according to Newton, there would be acceleration. Okay, so what we can see, this force that I am talking about, it is force due to the gravitation. So the acceleration that this force will going to create, we can call it as acceleration due to gravitation, and this acceleration due to gravitation is denoted by small g. Okay, so we have learned about two g's, one capital G. Okay, one capital G, when we write F is equals to g times mm by r square. Okay, in this formula we have learned about this g. This is what? This is the gravitational constant. Okay, this is the gravitational constant. It is universal gravitational constant. It means it will be applicable everywhere around the universe. But if I talk about this g, this is a small g. This is the acceleration due to gravity. The unit of this g is different. Okay, you might remember what is the unit. Try to brainstorm and try to figure out the unit. The unit of this g is basically Newton meter square per kg square. And if I talk about this, what can be the unit of this? Try to guess it. What can be the unit? You can see this is the acceleration due to gravity. Whatever the name I can give it to this g, it will remain acceleration. It is the acceleration that I am talking about. So what is the unit of acceleration? The unit of acceleration is meters per second square. The unit of acceleration is meters per second square. So whatever the acceleration I am talking about, it will going to have the unit as meters per second square. And we call it specifically because this will be specifically applied on the earth or near about the earth, or the objects which I am talking about with reference to earth. There we will understand, there we will use the acceleration due to gravitation. But imagine if I talk about Uranus and Jupiter. The force between Uranus and Jupiter, there would be the force due to this, and this G will be applicable at that place, but this G will not be applicable at that place. So try to understand the application. Okay, this G is with reference to the earth, this G is the universal constant. It will remain constant throughout the universe. Okay, this is what the Newton has derived. So now I am saying that due to the force of gravitation, there would be the acceleration due to gravitation. So what we will see in the free fall, the velocity in free fall, the velocity of object will increase. The velocity of the object will going to increase. Okay, it will gradually increase because of the acceleration of gravitation, or acceleration due to gravitation we call it. Okay, so this is how we can understand what exactly is the acceleration due to gravitation, small g. And first you note this, and then we will learn more about, we will derive that how we can calculate the value of this acceleration due to gravitation under this free fall condition. So first to note this, and then we will continue.